Hello, you are back on Scope, and today we are doing it ourselves. We're making our own science bits and pieces, and we're just about to check in with someone who makes their own rockets. But because I also like making my own rockets, I thought I might launch a few to kick things off. First up is a dry ice rocket. Now, how does dry ice make a rocket? Well, I'm glad you asked. You see, dry ice is the solid form of carbon dioxide, and when it warms up, it turns to the gas form of carbon dioxide. It's happening in there right now. And gases take up way more room than solids. So if I can seal up some of this dry ice inside a cylinder, well, the pressure should cause it to launch. The dry ice goes in with a little water to warm it up. The lid goes on, and now we move back. All that remains is to wait for the equal and opposite reaction. CO2 blasts down out of the tube as it pops, which makes an upward force on the rocket. Well, that was fun. Now I do have one more rocket to launch, but it's a little bit bigger, so we might take it outside. This is a water rocket, and sure, it looks quite different to the last rocket, but it actually operates under much the same principles. It's a container with water in it that launches thanks to pressurised air. The air is pumped in this time, and thanks to the tight seal, can achieve much higher pressures. When it finally does blow, the water jets downwards and the now lightweight rocket upwards. Oh no, I lost it. Anyway, I'm going to go off and find that rocket, but that shouldn't stop us checking out some more, even cooler, rocketry.
Hi, my name is Ari and I build rockets. I have built 26 rockets over the last 7 years and I've launched 246 of them. And I have one of the largest amateur rockets in the country. Let's check out some of the rockets I've already built. Basic rocket consists of a nose cone, airframe, also known as a body tube, and fins which guide it through the air. These rockets are all different shapes and sizes due to the material they are made out of, what size motor they will carry, and how fast or how high I want them to go. The smaller rockets can be made out of cardboard, while the bigger ones are made out of more sturdy materials like fiberglass. Let's go to my rocket workshop to look inside the rocket. Inside the airframe is a motor mount where the motor sits. This is what provides a rocket with its thrust. The motors start off as small size as A, and the biggest size you can get in Australia is an O. The motors are measured by impulse, which is its power. So, a B motor has a total impulse level of twice the amount of A, while C motor has twice the amount of B, and so on. How do these rocket motors actually work? They're not like a car motor and not at all mechanical. Rockets need propellants to launch. The smaller rockets use black powder, while the bigger ones use a solid fuel called ammonium perchlorate, which is lit using an igniter. The combination of extreme heat and pressure launches the rocket. The nose cone is connected to a shock cord, which then has a parachute connected to that to bring down the rocket safely to the ground. In the smaller rockets, the parachute is ejected once the motor runs out of fuel. While in the bigger rockets, electronic devices called altimeters release the parachute when it reaches its highest point called apogee. An onboard GPS lets us know its landing location. The nose cone and fins are not there just for decoration. They are to make the rocket stable and go in the right direction. The fins come in many shapes and sizes depending on what we want the rocket to do. If I wanted the rocket to go really fast and high, I would use more swept-back fins to get less drag. Right now I'm building this medium power scratch-built rocket which can take F to G size motors. Now to my favorite part, launching them.